Hi, everybody. My name is Greg Hancock, and along with Mr. Payback here, my friend Patrick Curran, we make up Quantitude. We're a podcast dedicated to all things quantitative, ranging from the relevant to the completely irrelevant. In this episode, Patrick leads us through the incredibly cool and powerful topic of regions of significance, a way to help unpack under what moderating conditions, treatments, and variable relations are statistically significant. Along the way, we also mention parallelism, Olivia Newton-John, going to the wrong church, laws in Vermont, pick a point, nan-aaaah-meters, the whack-a-doodle package of the month, kindergarten math deficiencies, the crossing guard creed, and the rosary landspeed record. We hope you enjoy today's episode.
So we're back in this weird timeline again where we're recording things before we've dropped other things that have already been recorded, and so who knows where we are when this actually drops. But what I do know is yesterday our episode 3 of the summer series dropped.
Yes.
Now, what was interesting about this particular one was I actually didn't hear it until it was up on the mothership. Now, normally we do lots of back and forth, and I make a pass and you make a pass, and for reasons I won't bore people with, I was on the road and didn't have time to do that. And you were a trooper and did a heavy lift and did the whole thing yourself.
Gave me some freedom.
2 quick responses to that.
Yeah.
One is I deeply appreciate the work you put into that. There was a significant amount of effort and it played wonderfully. Second, it did give you some flexibility in the post-processing that you wouldn't normally have.
Uh-huh.
I lost count of how many of the song titles I missed.
Uh-huh.
But also there was some very much bending of the rules.
Yeah, took some liberties there with some song titles, right? Because otherwise you totally would have gotten them.
Exactly. And if you had said something like, so with that development, it's like, welcome to the jungle.
Welcome to the jungle. We got fun and games.
And then I would have gotten that, right?
You would have, which wouldn't have been the 60s, but yes, you would have gotten that.
No, but in my formative years.
Yes, sure.
So since no good deed goes unpunished, I thought I would like to have a little payback here. All right. Now, folks, Dr. Hancock has no idea what's happening. This is for you ambushing me with the little quiz. Now, we are going to discuss today the development by 2 people, and this particular procedure is known by their paired names. And it made me start thinking about, other famous paired names. And I thought that I would give you the first name, and you have to give me the second name.
Oh, God.
All right?
So this is a little pop quizzy.
So it's a little pop quizzy. It's a little paybacky.
All right.
We are going to find as the recording continues as maybe my time would have been better spent preparing for the episode itself than sitting on the back deck trying to come up with name pairs. But we'll let time be the judge of that.
All right.
And this is going to be timed and speeded. And is going to be highly judgmental. Are you ready?
No, but go ahead, small man.
Newman.
Wait, I'm sorry. I just need to... Are these statistical or non-statistical or doesn't matter anything in the whole world?
We started.
Oh, it's a timer. Newman.
Okay, it's anything. All right?
Okay.
It's statistics, but it was really hot and humid on the back deck and maybe some non-statistics one kind of pulled in. Newman.
I keep thinking Seinfeld.
Newman!
I will go...
Okay, what part of the timed part are you not getting?
Cools! I will go Cools. Newman Cools.
Kolmogorov.
So I don't know what the hell you said, but I'm going to throw a vodka right back at you. Smirnov.
Gauss.
Markov.
Thelma.
Louise.
Gauss.
Hermeet.
Cheech.
Chong.
Newton.
John.
Abdul.
Jabbar.
Wallace.
Gromit.
Calvin.
Hobbes.
Millie.
Vanilli.
McDonald.
Douglas.
Pepto. I told you it was really humid last night.
Let's go Bismol.
Neiman.
Marcus.
Oh, for the love of heck. Neiman.
Pearson.
Penn.
Teller.
Key.
Peel.
Ike.
Tina.
Barbie.
Ken.
Adam.
Eve.
Thelma.
Louise. Is that for liability?
Did I do that one already? I'm marking
did.
them off here. It's all scribbling.
You did.
Ben.
Pass.
Jerry.
Okay.
Kramer.
Rao.
Newton.
John.
Newton. That is a good one. But let's go stats.
Thank you. Oh, okay. Rafson.
Homer.
Marge.
Lockheed.
Martin.
Laverne.
Shirley.
Johnson.
Johnson.
That's a good one. A second one. Johnson.
Neyman.
There we go.
All right.
And that brings us to our topic for the day.
How did I do? God, I'm sweating bullets here. How did I do?
Yeah, I don't know how you did.
I was a little fixated on Olivia Newton-John. I don't know how that happened.
Let's get physical.
What are we doing, man?
Johnson-Neyman. So over the summer, we had a blast talking about history, kind of where we came from and how we got to where we are. And one thing I hope that we were able to convey was how much really important work was being done a very long time ago. One thing that I think is incredibly underused is what's called a Johnson-Neyman region of significance and then an associated confidence bands.
Yeah.
And are you ready for this? Johnson and Neyman was published in...
I think I know.
Well, tell me.
Wait.
This isn't the continuing quiz.
Times New Roman. I actually didn't have enough information to answer that. I was just so...
But you were just going to blurt it out anyway.
Yeah, whatever. Actually, I think it was originally published like in 33 or something. And my recollection is it wasn't in a U.S. journal. I think it was like statistical something. Come on. That wasn't bad.
You are not going to get credit for statistical something.
It was like memoirs. It had memoirs in it.
Statistical Research Memoirs.
All right.
1936.
36. Okay.
Yeah. Well, you know what's interesting is there's some typos that are kind of like an STD where people cited other ones.
Yeah.
And it is sometimes cited as 1933, and that's actually incorrect. It's 1936.
Oh, okay.
But regardless, 1936.
I think this is a great topic. I think it is a topic that many people out there will not have familiarity with unless they've been knee-deep into moderation stuff. But I will confess that I don't know a ton about it. And I completely recognize it as an extraordinarily useful topic that I think just sort of sits off to the side. And I know that you had a number of papers on this topic. So let me just reframe this. As a trigger warning to listeners, you're probably going to hear a lot of Patrick talking. I think that's fair up front for us to let them know that.
Well, yeah, I have written a few things on this in collaboration with other folks, and I think it's a remarkable tool that is underused in our work that we typically do. But I need to count on you for keeping the guardrails on and shoving me back into play every now and then. So just the usual. Is that good by you?
Yeah, it's totally good. I assume that you have a really, really well delineated mental arc for the pedagogical experience, the journey that you're about to take us on.
Bonnie.
Clyde.
Okay, that was one I didn't ask. So, funny you should ask. Oh, and here's another one for you. Starsky.
Duh. Hutch.
Cain.
Abel?
Yeah, I was going to go from Starsky and Hutch to Old Testament.
Okay.
All right, so let's teleport way back to our favorite Irishman, Gossett, who is testing yeast for Guinness Brewery, and he develops what has become now to be known as the t-test. All right, we got two means. So let's bring it into the fore. So just making up example as we go along, which maybe is something I should have spent more time on last night, but I had priorities at hand.
Bonnie. Clyde.
So let's say we're interested in studying alcohol use in high school students. So 9th through 12th grade, adolescents. And we are interested, are there differences in average alcohol use for students who go to a public high school versus students who go to a private high school.
Okay.
All right, pretend like there's no nesting, all of this. We have one kid from each school, right? Whatever. But we got two groups and we have a continuous dependent variable. And we would like to know, is there a significant difference in the mean of alcohol use comparing public versus private school? All right, good old t-test.
I'm with you.
All right, the null hypothesis is the means are equal. The alternative is they are not equal. And if we get a significant difference, we say it is highly unlikely I would have observed my difference or larger if there was no difference in the population. In and out, nobody gets hurt. What can possibly go wrong with a frequentist perspective? All right, so we got the two means. Well, we're back with Gossett, we're back with Fisher, so we're doing a little bit of reminiscing about summer. And Fisher, who we all agree is a horrible person.
If we've learned nothing.
If we learned nothing over the summer. But Fisher developed ANCOVA, analysis of covariance. So what that is instead of just comparing two means, we're going to stick with two, it scales up to more than two groups.
Sure.
He said, well, wait a minute. Let's say we have a continuous variable. He looked at things like rainfall and temperature and cloud cover and things like that. Is he wanted to estimate and remove the effects of this covariate and then look at the adjusted means.
Right.
So let's say in ours, we say, well, I would like to do the group mean comparison controlling for a continuous measure of self-reported anxiety.
Ooh, okay.
So I know that on average, anxiety tends to be related to alcohol use. And I would like to say, when you control for the effects of anxiety, are there mean differences in the adjusted means above and beyond the effects of anxiety? All right, cool. Well, here's a couple interesting things. The big assumptions we make are twofold. One we're not going to deal with and one we are. The first is the covariate is linearly associated with the dependent variable.
Right.
All right, so you got a line and we're back to our adjusted mean moving up and down the line. So on average, if you're higher on anxiety, you tend to drink more. If you're lower, you tend to drink less. All right, so linearity, and we're going to leave that one alone. Although you can easily address it, we're going to ignore it for now. The second one, though, which was a poke in the eye to ANCOVA for decades, is homogeneity of regressions.
Yeah, parallelism.
Parallelism. That's a wonderful word. So everybody, I'm going to do a lot of Marcel Marceau kind of things, which one would think is not as effective over audio.
No, but you go ahead. I'll translate as needed. Now he's flipping me off.
See, it works fine. All right, so everybody picture in your mind's eye an XY axis. X is anxiety, Y is alcohol use. Now picture on that XY axis a horizontal line. What that represents is there is no effect between anxiety and alcohol use, right? As you move that conditional mean up and down, there's a slope of 0. All right, well, what if anxiety has a significant prediction? Let's say it's positive. That single line becomes a tilted line of some positive slope that on average, people who are higher on anxiety tend to drink more, lower on anxiety tend to drink less.
And this so far is irrespective of the school stuff, right? This is just a general relationship that has nothing to do with any other variables so far.
Exactly.
Okay.
Now bring in school. And what we're going to do is have a school-specific line. We're going to have a relation between anxiety and alcohol use within private schools and within public schools. All right, now what we're going to do is picture in your mind's eye that single line separates into two parallel lines so that one is the relation of anxiety within public, one is the relation of anxiety within private. The distance between those two lines is the main effect of school. That if on average private school kids tend to drink more, that line is going to be elevated. So instead of comparing two unadjusted means, the mean of alcohol use within each of the two schools, we want to build a model that compares two adjusted group means. So the means above and beyond the effects of anxiety. So I'm going to take the opportunity to expand on the pop quiz element of this, Greg.
Excellent.
Describe to me an XY plot that would show a main effect of group and a main effect of anxiety, but no interaction between group and anxiety.
Abdul-Jabbar.
You were right.
Okay. So first of all, I'm going to assume that X, in this case, I think you defined it as anxiety, and Y, which is your alcohol consumption, that they have a positive relationship. Higher degrees of anxiety mean that Patrick is going to go have more Coors Light as a high school student, something like that. There's a positive relation, but I haven't said yet for which group. Well, let's imagine that there's a positive relation whether you are in a private school or you are in a public school. So there are two lines now. If there is a difference in alcohol consumption between public school and private school, but the relation between alcohol consumption and anxiety is the same, then what you would then have are two parallel lines, two lines with equal slope, right? That parallelism or homogeneity of regression slope. And in analysis of covariance, if you have those parallel lines, and I cannot underscore that if enough, then the distance between those two lines, the vertical distance, represents a treatment effect after you have controlled for, in this case, anxiety. And if the two groups have the same anxiety on average, then you're not doing any adjustment to the means. All you're doing is controlling for extraneous variability in your outcome variable, which is not necessarily insignificant, right? That can be a very helpful thing. But if the two groups are starting off with different amounts of anxiety, then the two lines, while parallel, are shifted a little bit from each other. And the idea of analysis of covariance is that you can sort of equate these groups on X, equate them on anxiety by sliding their means up and down the line until you get to an average amount of anxiety. And that right there is often taken as a representation of the difference between the two groups after controlling for differences in X, in this case, differences in anxiety. But it all rests on the lines being parallel. How'd I do?
You get an 8 out of 10.
Okay.
And like my usual grading is I will leave it to you to determine why you didn't get those last 2 points. My entire grading rubric is based on capriciousness.
Okay.
No, that's exactly right. And anybody who has taught this has maybe given, and this is a really nice homework assignment, I give a bunch of empty XY plots on a sheet and say, you have an ANCOVA, you have two groups, and you have a continuous covariate. Draw the relation where there's not a main effective group or of X, right? Mm-hmm. That's a single horizontal line. Then I say, draw where there's a main effective group, but no effect of X. And you have two horizontal lines that are separated, and then a main effect of both. And those two horizontal lines are now tilted, but at exactly the same amount. So they're parallel. But as Greg highlighted, it is crazy important if you're going to do a main effect ANCOVA in the way that we've described, that those lines be parallel. Mm-hmm. For decades, if you failed that assumption, and there were a variety of ways that you could test this, it was actually encouraged in textbooks that you not use ANCOVA. Mm-hmm. You use alternative methods, or you use a different design, or you do separate group analyses. Until some of the historical strands that we talked about over the summer, it became available that you can bring in an interaction.
Yes.
So now what we have, where Greg left off, is we have two lines that are parallel and positive. One is for public school, one is for private school. And now all we're going to do is relax the assumption of parallelism. We're going to allow them to be non-parallel.
And if I put on my antique ANCOVA hat, that's really bothersome because that implies, at least for now, that the nature of the adjustment, the nature of the, I'll say, effect that anxiety might have on alcoholism could be different in the two groups. That doesn't bother me as much as saying that one group is going to get more credit for its anxiety and one group will get less credit. So you got to talk me through this a little bit more.
It all involves my 89-year-old mother.
The anxiety?
That, among many other things. We've talked on prior episodes as your mom calls you on Sunday night and says, honey, what is the difference in alcohol use between public and private schools? And you say, well, on average, if you're in private school, your mean is 2 units higher than if you're in public school. I just made that up. That's not tied to any literature.
Sure.
And she says, well, but there might be differences in school anxiety. Did you adjust for that? And you said, yeah. And then she says, well, then what was the difference? Well, if you're under parallelism, it's 2, no matter where on anxiety you are. Think about those parallel lines. You know what's fun today? Even though we're going to do some crazy cool stuff with math, we're never going to leave middle school. We have two parallel lines, and you move up and down the x-axes. The distance between those two lines is exactly equal. Indeed, that's what defines them as parallel. That means you have no interaction. Now make those non-parallel. Picture in your mind's eye running up and down the x-axis that again represents anxiety. Well, now mom calls and says, well, what is the difference between public and private schools as a function of anxiety? And you say, well, it depends.
Yeah.
At what level of anxiety are you interested? Because there's less of a difference on lower levels, but that difference begins to get bigger and bigger and bigger as anxiety goes up.
Those two lines are fanning out from each other in what you described, right?
Exactly. So it depends. All right. Now, as Greg just says, that makes you a little loopy. Because if you think about adjusting the means within the two groups, well, now you have different tuner depending upon where on X that is. Very cool. We have marched all the way up into like 1921, something like that. So for many years, if you failed the test of parallelism, it was often recommended that you not use ANCOVA, that you use other methods. But then remember, we talked about having the ANOVA-ANCOVA kinds of models and the regression kinds of models. And Cohen in 68 reminded us that they're all members of the GLM, and we can think about that as a multiple regression. So now, moving out of what we might think as a traditional ANCOVA, you actually have a two-predictor regression. Alcohol use is your dependent variable. You have a binary predictor that is public versus private school, and you have a continuous predictor that's anxiety. And we can look at the effects of school membership above and beyond anxiety. Indeed, we can look at anxiety above and beyond school membership. But we can enter the product term and explicitly model that as an interaction. And instead of saying, well, let's estimate and remove the effects of anxiety and look at what's left over, now we can address my mom's question is, what is the relation between alcohol use and anxiety within public school students? And what is the relation between alcohol anxiety within private school students? And we build that into a synthesized part of the model.
Yeah, and we had a whole episode, I think it was last year, about moderation, the idea that it depends. And in the ANCOVA history, as I recall, significant interaction was a death knell. And now we view it entirely differently. Now we say, oh my gosh, this moderation is so rich in the information that it has. And I think where we're going is ways of unpacking that richness.
We still haven't gotten to 1936. Because one of the big take-home points that we get from this, other than Greg can't put Jerry with Ben, dude, you get Cain and Abel and you don't get Ben and Jerry?
I'm going to the wrong church, clearly.
So we spent a summer up in Vermont and we did the Ben and Jerry tour, and they give free samples at the end. And my very young children at the time wanted to move to Vermont because they thought that you got free ice cream anytime you went out.
It's a law in Vermont, I've
It
heard.
was pretty funny. Once we build this into the model, it's exactly the same thing, right? But we're looking at it through a different lens. Now we are saying the relation between X and Y depends in part on group membership. And enter the stage 1977, David Ragosa.
Do we need like disco music, or what would we need right now for 77?
Ragosa has some crazy, creative, important papers in the late 70s, early 80s, mid 80s. Really remarkable. In 77, he did his dissertation on Johnson-Neyman procedures in ANCOVA and regression. He has a paper in 1980 in Psych Bowl and a follow-up in 81. And what he did is say, hey, these two guys, Johnson and Neyman, did this thing in 36. And we can make use of this here in really cool ways. So go back to that plot in your mind's eye. XY axis, X is anxiety, Y is alcohol use. They're two non-parallel lines. One is the regression of alcohol use on anxiety in public school, and one is the regression of alcohol on anxiety in private school. We just said, what is the difference in mean alcohol use as a function of group membership? It depends on what level of anxiety it is. Well, we can do what Ragosa called first, pick a point. And we're going to come back to this. All right, is if we're going to understand the nature of an interaction, and we talked about this on an earlier episode, maybe last season, I don't know, we talked about moderation. But the main thing we remember is it's fun to say pick a point.
Pick a point.
Pick a point, pick a point. Try it if you're driving somewhere.
Pick a point.
Pick a point. This is fun to say. Second, if the relation between X and Y depends on another predictor, let's say G just to represent group, then pick a point.
Pick a point.
Pick a point is, well, let's look at the relation between X and Y where G equals 0, and look at the relation between X and Y where G equals 1. Those are sometimes called simple intercepts and simple slopes. What is the group-specific regression between the predictor and the outcome? All right, we've been doing this for decades and decades. But go back to that distance between the two lines. That is the difference at that value of X that is the difference in mean of alcohol use between the two groups. What Johnson and Neyman did and what they came to call regions of significance is if those two lines are not parallel, they have to intersect somewhere, which means they reverse order. If it's on one end, group 1 is above, when it intersects, then it's below. If we take as a general statement that the difference between the two lines is the conditional mean of the dependent variable at that level of the covariate, at anxiety, Johnson and Neyman showed that we can compute the exact points on X where that difference moves from non-significance to significance and then back from significance to non-significance. It is a region of significance. It is over what range of the covariate is the difference between the two lines significantly different from 0 at some level of alpha.
That is really, really cool. I kept thinking of the lines as fanning out, but you're absolutely right. They're going to crisscross somewhere. They might crisscross in some region that makes no sense, right? It could be way down on a negative value of the anxiety scale when anxiety scale doesn't even have a negative value, but they are going to crisscross. And so as we imagine those two lines widening as anxiety, we'll say, goes up, then at some point you're going to hit a place where the lines are actually statistically significantly far apart.
And actually, as you move farther away from the centroid of your observations, you can actually have that go non-significant again because of uncertainty. It's very, very weird. We'll talk about that in a minute. You've got to be comfortable with weirdness when using these Johnson-Neyman. To make it very pragmatic, Greg is exactly right. Often with non-parallel interaction lines like this, by definition, they have to cross. Very often, it's not within the range of the data that we observed. It could be light years outside the range. I mean, it's a mathematical characteristic of the relation. If it's non-parallel, even by a nanometer, is that a real word?
Nanometer?
No, it's nanometer.
Pick a point.
Pick a point. Pick a point. Starsky.
Pick a point.
Dodge!
Damn it!
Is picture in your mind's eye, we have two non-parallel lines and our anxiety measure ranges between 1 and 10. We could apply the Johnson-Neyman regions and find that alcohol use significantly differs between the two schools between an anxiety level of 1.8 and 5.6.
Wow.
On average, any child reporting values in that range, their alcohol use significantly differs for the two groups. Outside of that range, it does not. That is the region of significance. Over what range of the covariates do the two groups significantly differ in the conditional mean of the dependent variable?
And the implication of what you're saying is not that somehow the lines bend back closer together, but that the nature of uncertainty is such that as we get out past that place, the noise is so big, it's really hard to call the difference between the two lines signal anymore out there.
That is exactly right. Now, to better understand that then brings in what are called confidence bands. We had the episode on teaching, and Andrea Howard talked about how we sometimes teach in a way that overemphasizes how precise things are. Our slope is 1.2, that we need to convey uncertainty and sampling variability. Well, one way we can do is extend these Johnson-Neyman regions to what are called confidence bands. All right, now I'm going to really bend your mind, all right?
Okay.
We're going to do an XY plot. X is still anxiety. Y, are you ready for this? Is the difference between the lines on alcohol use across all possible values of X. So you go out to your level of anxiety on the X-axis, and when you go up to a particular value on the Y-axis, that is the distance between the two lines at that point. All right, this is so cool. And I know it's hard to describe just through audio, and there are a lot of papers that show this super nicely. We can draw a regression line that shows what is the relation between a 1 unit change on anxiety and the difference between the two lines on alcohol use.
Okay, I think I get this. I'm going to say it to you. You ready? There are different levels of anxiety, and when anxiety is 1, there's a certain gap between the two lines. When anxiety is 2, there's a certain gap. 3, 4, 5, all the way up. Pick a point.
Pick a point.
And now what you're saying is keep the x-axis as anxiety, but now change the y-axis to just be that gap. And so we're looking at the relation between x and what we might call the treatment effect, right? But it's a conditional treatment effect. And now you plot a line for that.
You are exactly right. Pop quiz.
Okay.
What would that plot look like if there was no interaction?
Flat.
Exactly. Because it's an equal difference no matter where in anxiety.
Yeah, never changes.
What would that plot look like if the two lines were getting increasingly far apart as anxiety increases?
The line should be positively tilted.
And what if they're coming together?
Negatively tilted?
Exactly. So if you have a horizontal line in this plot, it means there's no interaction. And when mom calls and says, what's the difference between the two groups? It doesn't matter. You just pick any level of anxiety, go up, and it's 2. But if that line has a positive slope itself, then you go out to a level of anxiety and go up, and where it intersects that line is the difference between the two lines. But I'm not done yet.
Oh my gosh, it's already good.
Now, using the beauty of Johnson-Neyman, we can put in these butterfly bands around it. So there's a quadratic kind of parabola above that line and below that line. And then we can look at where do those curves intersect the x-axis, because that's going to indicate where that difference in the two lines is significant and where it is not significant. So in your mind's eye, picture a positive line with two butterfly-like regions, one above it and one below it, that are curved like a parabola. That is the confidence band.
So as I move up and down the anxiety scale on the x-axis, the line is telling me how big the gap is between the public school and private school in terms of alcohol consumption. But that gap has a standard error around it, and we wind up building what looks like a butterfly plot around so that the standard error of the gap associated with public school versus private school alcohol consumption, the uncertainty in that widens. And so that's this butterfly.
That's exactly right.
And I think what you said is when it starts crossing the x-axis, that means that the gap between public school and private school represented by the line now has as part of its confidence interval 0. So we can no longer confidently say that there is a detectable, statistically significant difference between public school and private school.
That's exactly right. And pick a point.
Pick a point.
Let's say you wanted to know what is the difference in alcohol use at a value of anxiety of 1.
Nice.
And you compute the point estimate and the confidence interval. And at 5, and you compute the point estimate and confidence interval, and 10. So you pick 1, 5, and 10 as your 3 pick-a points.
Pick a point.
All right, so you just have 1 point with a little plus or minus 2 standard errors, however you compute it. Now do it at 2.5. Now 1. Now 0.9, 0.8, 0.7, 0.6. a little point and confidence interval across the continuous number line of x, and that's where that parabola comes from. At any one value of x, that is the point estimate of the confidence interval. You're just doing it across the range of x.
Wow.
It is absolutely beautiful to see.
Yeah, so when we had an episode previously about moderation, the take-home message of that was, it depends. And it sounds like what we're doing here is we're actually quantifying the region where we can statistically say that it depends on this particular moderating or interacting kind of variable.
Exactly. Now, one final thing, and this falls under the do as I say, not as I do, because I don't think I've ever actually done this, although I sure grouse when people don't. Picture this final plot, all right? So as you're listening, I was going to say, if you're listening, I sent you yesterday, Greg, the guy sent the email to a listserv I'm on, and in bold underlined, he said, "Let me know if you do not receive this email." And my very first thought was I took a screenshot and sent it to Greg.
So I emailed the guy and said I hadn't received his...
Karl Popper would have something to say about that. Now, your final task. This is your project, your data. Picture in your mind's eye. X is anxiety. Y is the difference between the lines. The line of that plot is the difference between the lines at every value of X. The two bands, those parabolas, are confidence intervals taken at every value of X. Now, on the X-axis, put a box and whiskers plot of your own data. Put an interquartile range, mean, median, 95th percentile, 5th percentile on that X-axis. And you can see exactly what is the region of significance that's implied by the model, and does that overlap with the range of the data that you observed yourself? Because the model doesn't know where your data is. Sometimes these regions can both be outside the range of the data. As Greg alluded to, you might get a region that's -2, but your minimum value is 1. The model doesn't care. But imagine your interquartile range is between 2 and 8, and the region of significance is the difference becomes significant at 2.6 and becomes non-significant at 6.8. Think of the story that you can tell with that information that's based on Fisher's ANCOVA. Right? We're not doing some whack-a-doodle package of the month that you download. And no, I'm not insulting R. Don't email me. But this is like old school. How do we take information that we already have and arrange it in a way that is useful to us?
So I like everything about this example that you have said so far. And if I tie it back to what we talked about previously in our moderation episode, moderation really is just about interaction, and the idea of a moderator variable often depends on just the perspective that you take. Here originally, we talked about whether or not the gap between public schools and private schools in terms of alcohol consumption is itself moderated by or depends on anxiety level. So this is all really about the interaction between those two variables, a group variable and a continuous variable. But what if we have two continuous variables? What do we do then?
So this is where things get really cool. 36 is Johnson-Neyman, and they dealt with the ANCOVA as we've described. And it scales up to any number of groups. It's just easier to look at two groups. Everything we've talked about has been categorical by continuous, and you were exactly right. What about continuous by continuous? What it turns out is Bauer and I wrote a paper in 2005 in Multivariate Behavioral Research where we tried to tackle this very problem. And with Bauer's math leadership and me mostly doing path diagrams and citations, so that's the Bauer and Curran. But Bauer said, okay, well, look, if we take these two groups, get out of the ANCOVA mindset and embed it within the GLM, and grouping is just a vector in a design matrix, then it's just regression as usual. We can have categorical, we can have continuous, we can have higher order interactions. And in that paper, what we tried to do was to generalize Johnson-Neyman to continuous by continuous interactions. So let's imagine that instead of grouping, we'll give that up for now, and say anxiety and depression correlate with one another. And so what we would like to know is, what is the relation between anxiety and alcohol use as a function of a continuous measure of depression?
Nice.
Now we have a continuous by continuous multiple interaction. And we can arbitrarily define one to be the focal predictor, one to be the moderator. These are symmetric and they can be reversed. But for sake of argument, let's say that anxiety is the focal predictor, and we are going to look at the moderating effects of depression. Now mom calls and she says, honey, what is the relation between anxiety and alcohol use? And you say, it depends. At what level of depression are you interested?
Nice.
Because the magnitude of the relation between anxiety and alcohol use depends in part on depression. Exactly like the relation between anxiety and alcohol use depends in part on group membership. But now we have a continuum. It depends on depression.
Okay. We're using anxiety as a predictor and alcohol consumption as an outcome. So if you could, then you would look at the relation between those two, in theory, for every single level of depression.
Exactly.
Pick a point.
Pick a point. If we have a continuous covariate, that means an infinite number of values of depression.
Right.
You and I are busy guys. I've got to go pick up my kids in a few minutes. I am not going to calculate the regression between X and Y at every value of, let's say, your moderator Z, for lack of a better term. That's depression. So what Ragosa and others have advocated...
This is calculus. Is calculus coming?
Not yet.
I'm so excited. I'm excited.
Hang on, math geek.
Okay.
If we want to look at the relation between X and Y across values of Z, let's do a high value, a medium value, and a low value.
Pick a point.
Pick a point. Maybe one standard deviation above the mean, at the mean, a standard deviation below the mean. All right. Most all of us who are listening have seen some variant of this. It is a simple slope, a simple intercept, and you say, what is the relation between anxiety and alcohol use at a high level of depression, a medium level of depression, and a low level of depression? And we can get p-values for those that says, is that regression line significantly different from zero at a standard deviation above the mean?
Right.
Is it significantly different at the mean, or is it significantly different a standard deviation below the mean?
This feels very Aiken and West, like 91.
Yep, they had a wonderful little sage book on testing and interpreting interactions in multiple regression. That is a glorious little book.
Were you with Leona at the time when that was being cooked up?
Yeah, I actually had the honor of reading drafts of that.
That's so cool.
Steve was my dissertation advisor, and I was there in the late 80s, early 90s. So yeah, I was right when they were writing that. I made no contributions. I read drafts and just made comments, but that was it.
Nice.
But yeah, so high, medium, and low, all of us have seen the fan that's opening up of what are the three regression lines. But here's a couple of interesting pieces. So let's say, I'm going to make things up, the p-value of the regression of y on x at high depression has a p of 0.01. And at medium has a p of 0.03. And at low has a p-value of 0.09. Somewhere between medium and low, it moved from significance to non-significance. Well, don't you have a hankering to figure out where that is? We're getting close to your calculus.
Okay.
We're not there yet, nerd boy.
Oh my God. Okay.
But how do we do those pick a point?
Pick a point.
Well, what we do is we compute the slope. Let's just focus on the slope. Each has an intercept to give the level, but let's focus on the slope. We compute the slope at high depression. We compute a standard error for that, and we get a critical ratio. That's how we get the p. We compute the slope at a given value of depression for the mean, and we compute the slope at a given value for low, and we get those three critical ratios. We can take Johnson and Neyman and say, well, wait a minute. You have critical ratio equals point estimate over standard error. So you're going to give me the value of depression, and I'm going to give you the critical ratio that goes with it. What if you give me the critical ratio, and all give you the value of the moderator that goes with it.
So in order to be significant, what level of the moderator would we have to be at? Is that right?
That is exactly right.
Genius.
And that is moving from pick a point to regions of significance is what we can say is, well, if the slope between x and y varies as a function of z, at what levels of z does that slope transition into and out of significance?
And this is what you and Bauer worked on in 2005?
Yeah, so we had a handful of papers on this, and the first one was in 2005 in multivariate behavioral research. And with Dan's math chops, he was able to move from the discrete group case, embed that in the GLM, and generalize it to continuous covariates. And it's exactly Johnson-Neyman. It's just now we're going to go back to the weirdo plot. The one we left off with, remember, had anxiety on the x-axis, and the y-axis was the difference between the two regression lines. All right, now, Neo, you're going to take the red pill.
Whoa.
And the x-axis, which is our moderator, is going to be depression. The y-axis is going to represent the magnitude of the relation between our focal predictor and the outcome. In other words, our y-axis is the slope between anxiety and alcohol use at every value of depression.
The raw slope, the unstandardized slope?
The unstandardized raw slope.
Okay.
We're going to put all possible values across depression. Now, picture in your mind's eye. Go down to one standard deviation below the mean on depression and up. That's your pick-a point.
Pick a point.
Go ahead and throw a confidence interval on if it helps you sleep at night. Do another one at the mean. Do another one above the mean. Those are your 3 pick-a points. Now do it across the infinite number line, and you get this beautiful parabola on both sides. The same butterfly plot, but instead of the difference between the two lines, it is the slope of the relation between the focal predictor and the outcome at all possible levels of the moderator.
So the math of this sounds very, very cool. I'm feeling some quadratic equation, solving for unknowns to figure out where the points are, where you just crest over significance or inside significance. And this, don't take this the wrong way, but
okay, just a sec. We have a family rule. Nobody starts a sentence with that. But please, go ahead.
Okay. How did this not get done until 2005? This seems to me like such an important extension to be just kind of hanging there. I don't know why it wasn't done. Not that I'm not glad it's you guys who did it, or more accurately, that Bauer did it and you just tacked your name on it. But, I mean, this is a really important development.
Well, I did tack my name onto it, so, let's just be honest with one another here.
No, we've met.
But
Hi, this is Dan Bauer, and I can indeed confirm that Patrick basically just tagged his name onto the 2005 MBR paper.
First, we weren't the only ones, there were other people working in this area as well. Steve Radenbush had a wonderful student named Miyazaki who was doing some work in this area. And Dave Thyssen teaches all students never say, this has never been done before,
right?
Because someone is always going to show you something that was. But I would say that on my side of the street in psychology, this had not been generalized to our knowledge to the continuous by continuous and beyond, because we talk about three-way interactions. And the big part of that MBR paper was then we also brought it into the multi-level model. So how do you use these same methods for within-level interactions, across-level interactions, when you're in a hierarchical structured or even growth modeling like framework? And it's all quadratic expression. Remember in 8th grade, ax squared plus bx plus c equals 0, and you curse the dark as to when am I ever going to need to do this?
Is this today?
This is it. It's today.
Minus b plus or minus the square root of b squared minus 4ac all over 2a.
I was in your house unsupervised. I went down to your basement where you have a whiteboard on the wall, and from first principles, you derived the quadratic solution. And I just looked at it and I thought, oh, to be a child in this house.
Well, I mean, kindergarten is not teaching the kids what they need. So, yeah, it's true. So, yeah, from school, I remember that. That's burned in my brain. The main other thing I remember from school is I was a crossing guard in 5th and 6th grade, and I had to memorize prevention of accidents as well as the prevention of the violation of the law is the creed of all patrol members. Those are the two things I remember from school.
The main thing I remember as a child is, Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now at the hour of death. Amen. My brother and I still hold the land speed record for rosaries in the back of cars.
It's impressive. You're the rap god of the Hail Mary.
The Eminem of the rosary. But that's all it is. It's a quadratic expression that has two equivalent solutions. That's the negative b plus or minus. We get two roots. And what we're able to do is to say there is a significant positive relation between anxiety and alcohol use for children who report depression scores between 1.8 and 5.6. How freaking cool is that?
That is so useful.
There are a handful of papers on this that we really dig into these. Dan and I wrote that. We have another one in Psych Methods on how does it apply to latent curve models. And then Chris Preacher, when he was a postdoc here at Carolina, Dan and I worked with him, and Chris took the lead on this. And one of the other rate limiting steps of why hasn't anybody done this is there aren't a lot of utilities for doing this in practice. There are more now, and I won't do a laundry list of what's out there. But there's still no really clear way of doing it. I think Andy Hayes has some of this built into the process macro.
Yeah.
I mean, these are totally solvable. You can actually do these by hand.
Absolutely. There's a paper that describes how to do it within Excel. So people are trying to bring it to the masses.
Exactly. My favorite is Chris Preacher has online calculators, and he has a website, quantsci.org.
Right.
quantpsy.org, and he's got a whole ton of stuff. In there is probing interactions. There's one for OLS regression, there's one for multi-level regression, and there is one for latent curve models.
So many goodies there.
Chris has these remarkable calculators where you type in the values. It will give you pick a point. It will give you regions of significance, and damned if it won't create R code that you can submit to an R server that will give you the plots of the confidence bands.
Beautiful. And so that's what you and Dan tacked your names onto.
Yeah, exactly. This episode is part professional development. You know, it's just tack your name onto anything that comes along and you'll eventually get tenured.
No, you are just as smart as the people who are smarter than you, Patrick. All right, so I've experienced a lot of emotions hearing you talk about this. One is excitement. Another is a little bit of shame in the sense that I haven't taken more time to integrate this into my thinking because I just see so many possibilities and issues that should be studied, and maybe they have been studied. You would know. For example, and this is maybe an easy one, we don't always have just one moderator, right? We talked about having depression as a variable that potentially moderates the relation between anxiety and alcohol consumption. But what's another variable that could be acting as a moderator besides depression?
Sure, you could have, say, parental diagnosis of depression, of a major affective disorder. So does a child have a parent who has a diagnosis of major affective disorder?
So that's a yes or no?
Sure, could be binary.
Okay, so you've got the kid's own level of depression, and then you have whether or not there exists a parental diagnosis of this. Great. So now I've got these two potential moderators. Whereas before you had this vertical axis that represented the relation between anxiety and alcohol consumption and a horizontal that represented one moderator, I could imagine there being, for example, two additional axes, one that represents the kid depression, the other that represents a parental diagnosis. And so now I start to feel that you're getting a, whoa, three-dimensional butterfly, am I right?
That is exactly right. if you have a two-way interaction between two continuous variables, you have a single plot that has, y regressed on x as a function of z. And if that two-way interaction itself interacts with a grouping variable, you have one plot for group 0 and you have a second plot for group 1. And we did exactly that. We have a 2004, maybe, Psych Methods paper on probing interactions and latent curve models.
Okay.
And it was kind of neat. We had a continuous by categorical interactions, and we stacked those two on top of each other. So one butterfly plot for group 0, one for group 1, and then shaded the regions in within each plot.
Right.
And you can see where the regions overlap and where the regions don't overlap.
That sounds beautiful. And that was for the case where the extra variable was categorical. But you could imagine that variable being continuous, and it's really like, rather than clicking over from one butterfly to the other, it's like one butterfly sort of morphing into the other as a function of the other variable.
Exactly.
And that just seems incredibly realistic, that we might want to know, and this again ties back to our It Depends moderation episode, that you've got these knobs that you're turning for each of the moderators that you have. And rather than just saying some relation depends on where those knobs are, you're trying to figure out these regions where that relation is statistically significant versus not statistically significant. And it has to be not just one knob or the other knob, but it's where they are in combination with each other.
Exactly. Going back to Andrea Howard's point of trying to better convey uncertainty, these plots are wonderful at saying, okay, yeah, here your slope is 1.8, but your degree of confidence is a freaking country mile wide and doesn't hold for anybody in the observed range of data. It's augmenting what we already have with this really important perspective of where across these ranges do we have data and where do we have the greatest confidence in the inferences that we're making about the characteristics of our data.
I think it's really empowering, honestly. And it makes me think of a couple of other issues. One, you mentioned that there are extensions of this into the growth modeling world, as well as multi-level modeling more broadly. Can you say just a tiny bit about how those play in there?
Yeah, and it's in any setting where you have an interaction like this. Anything where one thing depends on something else, you can take this approach. OLS regression, multi-level, interactions within level 1, interactions within level 2, cross-level interactions between level 1 and level 2, growth models, 2-level growth models, 3-level growth models, predictors of slope. It's all the same quadratic expression, and you fit your model, you pick off the values that you need, and you plot them in this way that has been around for 80 years.
In the growth model, is it that you have a slope factor and there are regions where the slope is not statistically significant and regions where the slope might be statistically significant as a function of some covariate, and you're defining those regions where the slope differs significantly from zero?
That is precisely right. So we have an example where we have developmental trajectories of antisocial behavior. And on average, there is a linear increase starting from kindergarten through elementary school. On average, antisocial behavior increases. And there's a linear slope and there's significant variance. We bring in a time-invariant covariate of cognitive stimulation in the home, and it significantly predicts slope, so that the magnitude of the relation between the passage of time and antisocial behavior, that is the growth trajectory of antisocial behavior, depends in part on how much cognitive stimulation you were exposed to in the home at baseline. You can apply these pick-a-point and regions, and you can show that across lower levels of cognitive stimulation, there is a significant positive increase in antisocial behavior over time. But at a particular value of cognitive stimulation, that trajectory becomes flatter, flatter, and flatter. And at that region boundary, it becomes non-significant.
There you go.
And oh my gosh, to write a discussion section that the model implies there is not significant development in antisocial behavior at cognitive stimulation values of 2.3 and above is crazy insightful.
Absolutely. And I think about just about any kind of analysis. Not only can I think about, well, to what extent do those results depend on other variables, but then you just add on the extra layer of defining the regions where those things depend to a statistical degree. So this to me is potentially just incredibly empowering.
And there are a couple of ways I think this stuff could be extended. One is demonstrative papers to bring it into substantive applications. People need to know about these things. People need to know demonstrations of, well, how do you do this? How would this enhance your interpretation? How would this enhance our external validity? For whom can we generalize there is potentially a meaningful relation, and for whom can we not? I mean, the tentacles on this are really far-reaching. So one could be kind of a pedagogical, demonstrative dissemination kind of piece, but there are also a ton of unique extensions and applications that I think that a clever person could say, okay, well, these guys kind of pulled out this 1936 thing and polished it up a little bit. How can I build something new from this? And I think there are many, many interesting directions that could take.
Yeah. And I hope that some folks out there who are listening to this can think of some of those places to take this.
Wait. Before we sign off?
No.
Watson.
Crick.
Simon.
Cowell. Benet.
Garfunkel. Sonny.
Wait, what was wrong with Simon?
It wasn't the one I wanted. Sonny.
Okay. Cher.
And Captain.
Kirk. Tennille.
Love will keep us together.
Goodbye, everybody.
Okay, take care. Thanks so much for joining us. Don't forget to tell your friends to check us out on Apple Podcasts, Spotify, or wherever they go to pass the time before their children are sent home to quarantine. You can also follow us on Twitter, where we are @QuantitudePod, and visit our website, quantitudepod.org, where you can leave us a message and listen to past episodes. And finally, do all your back-to-school shopping with Quantitude merch from redbubble.com, where all proceeds go to donorschoose.org to help support low-income schools. You have been listening to...
Excuse me, Greg?
Oh, hey, Jiffy. Are you okay? I'm doing the episode exit.
Well, I was hoping that I could help out. My agent says that I should contribute more to the creative enterprise.
Oh, okay. Do you want to try this part?
Sure.
You've been listening to...
Got it. You've been listening to Quantitude, the podcast still hoping to have a region of significance.
Not bad. Okay. Well, one of the themes of the episode was paired names. So how about I throw you some paired names and you see what you come up with?
Okay, cool. Hit me.
This week's episode has been sponsored by Greenhouse Geyser.
Greenhouse Geyser. What happens when a thermal spring erupts in your arboretum? Greenhouse Geyser.
Okay. And by Spearman Brown.
Spearman Brown, whose formula was foretold by the oracles.
Ooh, the prophecy formula. Very nice. All right. And by Dun Bonferroni.
How do I like my bonferroni done? Al dente, with a nice carbonara sauce.
All right. And finally by Kaplan Meyer.
Kaplan Meyer. So important that your survival just might depend on it.
Nice. All right, go ahead, buddy. Bring it on home.
This is most definitely not NPR.